Hey, everybody. Thank you for having me. It's my first time here at Build Stuff. There we go. I'm from the United States. It's my first time in Lithuania. And we have a lot to cover. And I figured let's dive into code. Let's dive into engineering. Let's talk about real things. So yeah, I work at Microsoft. I work in the Azure reliability team. So when outages happen at Azure, I usually am there analyzing them with some AI tooling that we're writing, as well as manual review. All my code, all my demos are out on GitHub. So if you want to go out to my GitHub, you will find all of my talks and all of these samples, and you can dive into them deeper. I will also share this at the end. So I'm going to cover a bunch of things around what is configuration and how Framework has handled it, how modern.NET handles it, and then just diving into the configuration system, including some options patterns and some other really cool things that we can do. When I talk about configuration, I talk about things like settings, like numbers and values, knobs and dials that we tweak, maybe feature flags that we turn on and off for users, or secrets, which please don't check in connection strings or keys if you can. Please use RBAC and manage identity where possible. But all of these things are configuration. And if we look at the historical lens, a lot of times I remember growing up, starting in this industry, we had a dev branch and a QA branch and a prod branch, and we had different builds for each. And all the configs were checked in, and we would put the dev build out on dev and the prod build out in prod, and they were never the same code base. They always differed. It was always a nightmare. Modern day stuff, we have a build once, deploy many times wherever possible. And the only thing we change is our configuration. We put the same bits everywhere, either a container or a deployment or a package of some kind. And so when we dealt with Framework, for those of you who didn't, we had key value pairs. We had this static configuration manager class. Dependency injection wasn't part of the equation at all. We had this kind of difficult syntax, XDT, and we used slow cheetah. Unit testing was hard. Like, we had this stuff with the various keys we would add, and we would do this XDT transform to try to change them between environments. It was a nightmare. Anyone remember this? Did anyone feel this pain? You hated it, right? Yeah. So now we have modern.NET. When I say modern.NET, I mean pretty much .NET Core, anything from .NET 5 up. Like, they've just been building and improving on it forever. So you have configuration sources. These are things like real files, like JSON files or environment variables, command line options. You have all of these different things, even custom providers you can make, custom sources that you can make. They're handled by providers. The providers get registered in an order, and they're processed by the configuration builder, and that spits out an IConfiguration. And this is actually part of the injection system. It's dependency injected into modern.NET. So if I have multiple JSON files, I can set different settings in various parts. I can then add an environment variable. I can layer in command line arguments. And what's going to happen is it's going to be kind of compiled and built into one final object that is the unification of everything. So if I define environment or DB twice, like I do here, it gets overridden by the ones farther down on the chain. And we're going to talk about the configuration chains. We can also do bindings now in modern.NET. So we can have complex objects that get mapped to real .NET objects. So not just strings, but very similar to how we do model binding with APIs. So we can pass things over and have them build classes, even nested classes, without problems. If we're worried about hierarchies and things getting flattened, they get stored inside the configuration system with a separator, usually colons, but you can also manipulate those on your command line or environment variables with underscores. And we're going to get into all of this. I have a lot of demos that we're going to try to get through. And out of the box, if you do .NET New, you're not going to get any configuration in your console app. But if you're using maybe a host builder, or you're using a web host builder on ASP, you actually get quite a few things like ASP, JSON, or app settings JSON, and environments, user secrets, environment variables. And I'm going to show you how all of these plug together and how they work together. We have JSON providers, XML. If you want to write an INI file for Win32, hey, we got you covered. There's one implemented. And there's a ton of other providers that we can leverage for testing, like in memory, as well as if you need to do a key vault or an app config to pull in feature flags. Pretty much all of them just need a reference, and then you can add a file. You can make it optional. You can even do hot reload. Same with XML or INI. And then we can do environment variables. So I want to, I think I have my demo slide coming up because I want to get into the code. But like colons, you can't always use a colon on Windows. So like if I'm setting environment variables, I might need to use double underscore. But like those are just little things to pay attention to. There's built-in ones for .NET and ASP that also drive modern .NET, which if you've ever used a web app in Azure or app service, if you've ever gone to settings, you'll notice there's a lot of variables with like ASP.NET underscore, .NET underscore. Those are actually tweaking and changing the underlying .NET environment that you can control around environments or endpoints or URLs. Like you have tons of configuration in these. So let's get into the code and let's talk about some of the things that we just discussed. So again, all of my demos are out on GitHub, but we're going to start with, just do a basic console. So I have no config. If I want to change my configuration on this, I've got to manipulate the strings. But if I want to do something like a generic host, where I'm using a host builder, I'm not doing anything here, and I have access to configuration. It's already pulled in my app settings. So I've got a greeting and an environment here. And so just out of the box with a generic host, by .NET Run, this adds a whole bunch of things. This adds the like persistent life cycle, and it's great for workers or background processes, but it's pulling in my configuration that I've got right here, and I'm accessing it just by accessing like a key, configuration greeting, configuration environment. I haven't done anything to set up any sort of host. But let's just roll it back. Let's just start with the basic .NET New Console, and let's add configuration by hand. So this is where we're going to say, I would like a configuration builder, and I would like to add a file config.json. Like it doesn't have to follow the traditional app settings. It can just be whatever, and I'm just going to access it. You add the JSON file, you build your config, and now I have access to configuration. This has like one reference or two references here about like I need extensions configuration. But with this extensions configuration, now I have kind of rolled and controlled my own like choices in configuration. So I can run it. Hello dev, QA. So really easy to take that same bits and deploy them out. You know, environments are the same way. I can just say add environment variables. It's one additional line in my program settings, and I didn't change anything else. I'm not changing how I access configuration. The point I want to leave you with as we kind of go through some of this, and I'm going a little quick because there's a lot of content to cover in a short time. Once you've set up configuration and the things that flow into it, you access them the same way, whether it's directly accessing config or doing any of the other stuff that we can do. So I can access command line arguments. I can, environments. Greeting, hi. I can pass in a greeting, or I can not. I don't change the code, but it's just being funneled into the configuration system without a lot of extra overhead. One thing you'll see a lot is people using in-memory collections to manage their configuration, specifically for testing. And I have some demos later on where I'll cover more complex testing scenarios, but if you just need to build a new config for testing, build it in memory. You don't have to go through all this extra process of files and settings. I do want to call out user secrets. If you're not, who is not familiar with user secrets? All right, a couple of hands. So it's not encrypted and super complex, but it solves a specific problem of a lot of times people are adding connection strings or things to their configuration. So I might need some sort of secret here. But I don't want that checked in. I don't want to add it to my repo, so I accidentally push it up to my GitHub, and now everyone has access to the secret or certificate or whatever. So user secrets, when you set up a user secret, it adds a key into your CS proj. And you can actually see this very easily with like .NET user secrets list. So I don't have any right now, but I could set one. I could set greeting, can't type today, to hello. So it'll set it my secret store. And if I list this, now it's displaying the contents of that secret here. This is not in this repository. This is not in this folder. But this GUID here is going to be stored in my local settings. So it's still on the hard drive. It's still on my laptop, but it's in my like user local settings, roaming, Microsoft, in a plain text JSON file. So be very aware it is plain text. But if we go out to .NET user secrets, it will actually list the two places where they are. Yeah. So on Windows and on Mac, these are just text files. So be aware of that, but it will let you have settings that you don't check in and kind of protect you from being a little silly, accidentally checking in secrets. I highly recommend you use them if you can. So, I had the basic sample with greetings and environments. What if we have nested objects? How do we access the nested things? And I kind of showed you on a slide, but I haven't changed anything in loading it. I'm still loading it the same way. The only difference is now I'm using a colon in my access here to reference it. So you can access hierarchies via colons. So it's doing it in red. And I could do it with command line. And I could do it with environment variables, but I would have to do greeting __ color, just because of how file processing on Windows works. On Linux or Mac, it might be a little different. So we can easily continue accessing everything the exact same way. And again, I do apologize about moving a little quick. I just want to get to some of the more complex stuff. Now, what about, I hate doing that colon thing. I really don't like having to access nested properties, and I want a quicker way to do it built into .NET. There's lots of libraries out there that will help you do command line parsing, but it actually already exists out of the box. You can provide an array of mappings, and so before where, I might need to do -- greeting color blue, now I can actually, with the mapping, am I in the right folder? Should be in the right folder. Oh, color. I can't read. There we go, color. Now I can have a more user-friendly way to expose the command line options without exposing all the internal implementations of my settings. So these are some cool things you can do out of the box with those. There's even, like if you want to do key per file, you can bring in a path and set that up as optional, and you can come in here and have different sorts of keys if you need to. Same with Key Vault. So I leverage Key Vault through RBAC. So I'm using managed identities or default Azure credential. And I'm loading the configuration to get the name. Like I'm saying, hey, go give me that Key Vault name. And I'm going to add Azure Key Vault. with my default Azure credential. So I have a little bit of syntax at the beginning for Key Vault, and the documentation is really where I would go to implement this, but I'm not really changing anything else. I'm still just referencing everything how I would before. So I don't want to keep beating a repetitive point here, but we're in a place where once it's in configuration, and you can now start doing things with it. All right. I'm going to skip over that one. I'll quickly mention dependency injection. Like once you've built your configuration, you can say, I need to get a service for IConfiguration, and then you can reference that and just use it however you would like. But we're going to show a better way through the options pattern in a few minutes. Another scenario you might need, which is just some weird syntax that you'll occasionally see, is what if you need arrays of things? I need arrays of IP ranges. I need arrays of versions. Well, unfortunately, they're numbered in the config. So like they're numbered there, so that's a little bit annoying in that you're going to have to validate and check like individual ranges to see what's there. But we're going to talk about some great ways to protect yourself. So looking at that, there we go. We're pulling out individual properties and IDs. But we're going to talk about how to do this with named options. So let's say I want to build a markdown generator. So I've got some config. It's really poorly written. And I'm going to just access my config. This is boring. Like this is repetitive. It's not good practice. So let's go through and refactor things a little bit to start breaking it down by type. That way I now have a little bit more configuration I can do for PDF output or doc output. Well, I'm still, like I'm able to access things, my PDF template, my doc template, but this is still very, very repetitive. So what if we start looking at something like a class? Like I want to have a class and I want to just say, go load PDF, go load whatever. So now what I can do is I actually have a couple of different ways I can do this. You can say something like, give me an object, and once I have an object, bind it to the configuration. So what bind does is it will load the configuration and set each of the properties on your object to the things from settings. So bind works with existing objects. But let's say you don't want to have an existing object. You just want one instantiated for you. You can use a get. So a get will instantiate a new object and assign it to you. With gets and with these type of objects, they have to have public getters and setters with parameterless constructors, very similar to web API binding. So yeah, we can do the gets, and now I can have methods that operate on objects instead of all these individual properties. Yeah. All right. So we're going to do some more complex things with these. Starting to like actually have intelligent objects for your settings for different parts of your application. Like this is where I would recommend you start moving to. I'll quickly show you another thing I do a lot, which is I will have, for some settings potentially, I might have some different high-level things checked in, and then I'll use app.config or Key Vault to differentiate between them. But the annoying thing is on .NET, if you do .NET -- environment, and you say something like staging, what will happen is this will set ASP web host environment, but it won't necessarily set your .NET environment, and you actually have to do some overrides. Like they changed this with .NET, I think 8 or 9, where like environment wasn't being passed all the way through. It would work with ASP, but it wouldn't always work with the command line stuff. So I just want to point that out, that if you're trying to use environment to switch between configs, you sometimes have to put a little bit of extra code in there to make everything synchronize. So let's get into the options. So options pattern. So remember I said we don't usually like to just inject your whole IConfig. Like one, that gives you access to every single setting in your system. You don't need that. Most things you want really tight settings passed in, so you want separation of concerns and segregation. This is where I start making these option classes like we just saw. Like I said, public constructor, public read-write properties. There's actually 3 types of options. There's an IOptions, there's this this snapshot, and this monitor. And I'm gonna show you the difference between the 3, but like these 3 categories here are the main differentiators. IOptions and IOptionsMonitor are singletons, so that will definitely affect your services. IOptions doesn't support reloading in any way, and it also doesn't support named options. There's also some performance considerations between these 2. So snapshot is usually used when you have a request and you're kind of passing it through the request chain where you want that kind of snapshot with a scoped lifetime. But it can be recomputed, like it can be expensive if it's like computed every request, but this is really good for your web apps. Like this is what you want for the most part. The monitors are if you have really long-running web services or really long-running background services. So let me go show you those demos real quick because it will make everything clear. And again, we have limited time. Usually this is an hour or so talk, so I'm sorry if I'm going a little fast for everyone. But all of the code and samples are up on GitHub, so please spend some time looking through them. So let's just start with providers. So this was .NET New web app. And you can see, I actually can see all of the different orders the providers were loaded in. So it'll look at in memory, and then that will get overridden by ASP.NET Core, and then that'll get overridden by like some .NET, and then that'll get overridden by like JSON, and then your app settings JSON environment. So this is a great way to see how things are processed and how you can override and control stuff. But let's say I want to look at my injected config, looking at the code. That would be me just saying, hey, inject my configuration. So I can just do IConfiguration and have that dependency injected into my pages, my services, my whatever. And I can do that same thing I did before. Go get a section, so get a part of my app settings, and map that to a file option. Just do that. And I add them to a loop, essentially. And I'm just referencing the class. Please don't just inject your config. So let's look at options. So if I look at IOptions of T, so let's see how this gets injected. So with IOptions, I have an IOptions of a class called Markdown Converter. And in my code base, if I come down here, there's this Markdown Converter. This is a class that has multiple classes inside of it. So it's got multiple things. And in my program file, I've pretty much done one line. This one line and that class wire up the support for IOptions and IOptionSnapshot, dependency injection, all of it. So it's saying, hey, here's a class, Markdown Converter, configure it against this section. And that enables me to do the dependency injection. That enables me to do the IOptions. And so now I go markdown.value, and I have an instance of the class. I can use this. I don't have to change anything, but now I can also do IOptionSnapshot with the value, and I can do IOptionsMonitor of that class. But notice this one says current value. So let's look at some of those differences. So like PDF is true. PDF is true. What if I go into my settings while we're here, just together, and I say false? So on my snapshot, this is now false. It just changed. Same with monitor. This is false. Because they support reloading. But IOptions does not support reloading. This was a singleton that got created, doesn't reload, so it's true until I restart the application. Now, I will see false here because it's getting the latest state of the configuration. So reload is one of those things that's the difference between them. The other, like I said, was singleton versus being able to be scoped. So I have a service here. This is still showing true, even though I'm referencing a service. And the problem that you might run into if you're not careful when you have things being injected into services that you consume somewhere else is, if you're not careful, you can end up injecting like a singleton to it. Like I'm trying to do a transient service. Cool, I have a transient service, but if I look in here, my transient service is just using an IOptions. So it's using that singleton. So even though my code is being per request, I have an old configuration object and it can actually cause problems for me down the line if I'm not careful. So that's something to be aware of. And then let's see if there's, nope, nothing else on this one. All right, so let's look at named options. That's the other big difference between snapshot and monitor and IOptions. So looking at our code, the main difference you're going to see is I'm saying I would like a named file option. I'll call it PDF, and I want to bind it to this section. So having that first, having two options into the configure lets you give it a name. So I can name that particular option PDF, and I can name this particular one doc, and I can name that one HTML. And so let's say I had different backend services or different configuration implementations. I wanted each one to have a different name. How you would access that in like your snapshot is you do, I have an snapshot of file options. So it's the type of the class. And then you say, get me the named object I care about. And these are important because some of these things are used in Aspire later on, which we're going to get to, because Aspire is built on .NET configuration in a lot of ways. So monitor and snapshot can both work with these getting named objects, but IOptions cannot. So if we try, there is no like get doc. Like this fails and complains that it's not implemented. All right. So I would definitely look into those. Let's look at app.config real quick. So I'm a big fan of using something like Launch Darkly or Optimizely or Azure App.config, any of those that let you do feature flags. And one of the things you can add with Azure App.config, besides the normal endpoint default Azure credential, is you can have it refresh from the service on a cadence or whenever you want. You can actually optimize this in some ways. And if you're not familiar with, did I just break something? You always got to break a demo. I delete and restore stuff a lot, so usually I have a setup script, which is in there so that you can kind of see how I reset a lot of these things. Like I'll go and reset settings where possible and yeah, clean up endpoints and things. So that should reset things. All right, let's try running it again. while I'm waiting for that. Oh, there we go. So it just needed a little reset. So the way Azure App Config work, if you haven't seen it, is you get a service, you can look at your configurations. So let's say you have some settings here that you want to manipulate, and if you'll notice, this is set up exactly like the .NET config. There's sections with colons and hierarchies, and you can set colors. So right now we have white and black. And if I come over here, I can edit this and change settings, because maybe I want to make it black on white. Or maybe I want to do something like a feature flag and set that for different people. And I want to be able to change this without updating my website by hand. Oh, wait, it didn't update. The reason I didn't update it right then, by the way, is I actually set it to refresh, and I set it to watch a sentinel. Like, you actually will spin up money and bandwidth by like pinging the endpoint constantly, looking at every single key. So you can actually set it up, like I did, to watch a sentinel. And so when it sees this one value change in any way, then it will update everything else. So I can be a little bit more efficient with applying changes. And so now that I've updated that one sentinel, I can quickly make changes to both HTML and CSS, or I could do backend tweaks to my configuration. But if I go look at what I had in the code, besides setting up this auto refresh and the sentinel, and oh yeah, I configured a setting with the section, just like we've done in the past, that's all from app config. That's not even in my settings file, because it doesn't matter how it gets into the settings. Once it's in the settings, it just works. Where was it? I think it's in my home index. So I injected the configuration just to show you, like, configuration is configuration is configuration. It doesn't matter where it comes from once it gets in the system. You can do really cool things with it. I also use it for, and I'm wondering if I broke this one too. We'll find out. I only have like 30-something demos. We're mostly through it. It's fine. It's fine. Got 12 minutes. We're good. There we go. Didn't break that one. All right. So let's say I have a feature, beta feature that I have up here in my feature manager in Azure App Config. So see, it's on right now. Well, I could also come in and turn it off. So feature flags, just like the other things, get loaded in the configuration system, but what app config will let you do is you can actually have these tweaked by different reasons. Maybe it's 50% of users. You want to, A/B test. Maybe you want to do a gradual rollout and roll out 10 or 15 or 20, 50% of people at the time. You can set up a feature with Azure App Config, and you can come over and reference it, and then you can do, tweaks and variants here in App Config, and then your code just slowly starts turning it on and off for people to get results. So, and again, you don't have to do anything in your code. You pretty much just reference it like you would any other setting. So I have my endpoint, I have the refresh, and I just say use feature flags with, every 5 seconds, go check my feature flag. So it's a great way to get started doing this as well. All right, let me go back to testing. Yeah. So yeah, in-memory testing, setting up in-memory collections for APIs and endpoints or various settings. I have a problem that I'm sure some of you have run into. Has anyone deployed an application, it starts up, it's running great, and then someone hits an endpoint and it blows up because of bad config? You ever had that happen at runtime? Not at startup? So a lot of us love data annotations. I love them on models. I can set stuff required. I can say it's a URL or a range. But But one of the cool things we can do is we can validate our configurations with data annotations, and we can actually validate it on startup. So it'll tell you at startup if your application is misconfigured and fail fast, which is great for containers and containerized workloads. You can also do custom validation. So instead of just the data annotations, you can do some totally cool custom logic. And you can turn this on, like I said, at startup, catch everything, have a very clear error message on what's happening. And let me just show it to you, because we have limited time. So, where's the validation? It's right in front of me. So, basic web app here. Let me make this small. Required URL, I got some regexes, I got some values, everything looks good. And I got some settings right here. So great. Let's take a look at this. Whoops. We got our application running. We can come up here and we see information about our event, but I see retry times is 0. 0, I think, should be an invalid value. I don't think we should ever be able to say you never retry it. So I'm going to come down here. My problem was I said range 0 to 3. I'm going to change it from 1 to 3. I'm going to restart my application. Doesn't start up. I guess I'll read the error message. I hate doing that. Let me scroll up. Value for retry times must be between 1 and 3. So I can't even start up, right? Because I have a bad config. So I have to come in here and I actually have to add the appropriate setting. I think I'm looking at the wrong. There it was. Webhook. There we go. Try it again. Now that I have a valid configuration, starts right up. Refresh this. So I can stop bad behavior before it even starts by having protections around our config. What's more, in addition to just a normal data validation, I can actually make my own validate options. So I can make my own logic. Maybe I want to have a validate method where I come in here and I look for custom regexes or pattern matching. Or if I don't want to do that, besides the validate annotations, I can use a validate method and just do some random little .NET logic here to complain about too short of a URL or starting with HTTP, and I want to make sure that's validated on start. So if I go back to my app settings and say, hey, this is HTTP, and I restart it, it blows up. Webhook must start with HTTPS. So, great way to enforce this right on startup to make sure that we're not doing silly things. And then there's all sorts of, since we've got about 6 minutes, let's see here. I'm going to skip a couple. I would say please go out here and run these, but yeah, this is, there we go. I just wanted to show this. As soon as I save it, like you can control how you handle reload and refresh. Yeah, like you very much have control over these. Same with logging, collections binding. I'm going to skip to Aspire. Who's seen some great talks on Aspire or familiar with Aspire? All right, so Aspire, for those of you who didn't, raise your hands. It is a great way to orchestrate some of your different applications, kind of bring defaults to modern .NET development. And so you're going to see things like an app host file, where you're linking projects with names like API service, and you're saying, hey, my web front end needs a cache, it needs an API service. And I have a service defaults class here that actually defines OpenTelemetry and defines a dashboard and resiliency and service discovery. And what's awesome about this stuff is it loads in a dashboard so you can do dynamic debugging and open telemetry, and everything is built on .NET configuration and all the things that .NET already had in it. It's added these. I need to do that. So let's just go here for a second. So I said my web front end depends on my API service. Well, if I come over here and I say view details, it's going to show you the path and the port. And, hey, here's some addresses that it's listening to. And here's a reference for API service and some back references. But this is where it gets cool. Here's the environment variables. Remember all those ones I said existed to control how ASP works, like my environment or this or that? They're all here. I can go look at them and see the endpoints. But there's also this one, connection strings cache. There's also another one, if I go a little farther down, called services, API service, HTTP 0, and HTTPS 0. So these are just environment variables that Aspire is putting into my web front end. If I go look at my web front end, when it says add Redis with cache, it picks up by convention with Aspire that there's connection strings underscore cache, and it uses that connection string here to connect to Redis. When I say API service, it uses this type of syntax, HTTPS plus HTTP API service, to go look up services, API service, HTTP, and it figures out the host and IP and port and all that, and it wires it up. So like Aspire solves the problem of I need 8 windows where I've started my NPM front end and my React front end, my Python back end, the Redis container, the database service, and then I have to copy IPs between them. This solves it all just using the cool things already built into .NET, the configuration system. Now, a couple of final things. Try not to store secrets in your app settings, like don't check them in. When possible, don't use connection strings, don't use keys, use managed identities, which whatever provider you're using, use managed identities, use role-based authentication, like, please. If you have to use them, try to use user secrets, try to use key vaults, like use those things. What you're gonna see for a lot of people is they're gonna use environment variables. So they're gonna build a container or an application and then load it into Kubernetes or container apps or something with the valid information. Or on Kubernetes, they might use, where was it? I thought it had a slide on it. They'll use the CSI secret store driver to like put Key Vault into Kubernetes to inject it into .NET. And then yeah, Aspire does all the orchestration, has the app host, all the shared cool stuff. And we have about 2 minutes for questions. So please go out to my GitHub, but questions from anybody. Sorry I flew through so much, but had to shave off 20 minutes, 15 minutes.